Struggling to take care of your garden and wish that someone else did it for you? Well, this project is here to save your day. Meet Agribot, a smart agricultural robot that monitors the moisture level of the soil and waters it wherever the level is low. We are going to modify the 4-wheel drive robot that we previously made in one of our videos to make the Agribot. Click on the card above or the link in the description box for finding out how to make the 4-wheel drive robot. Let's begin. For this project, you will need the 4-wheel drive robot, a valve, a chassis, motor clamp, a servo motor, a servo horn, a soil moisture sensor, a DC water pump, a pipe, an ice cream stick, cable tie, a LiPo battery, relay, spacers, jumper cables, bottle, and some nuts and bolts. Let's begin by setting the servo angle. We will set the angle to 90 degrees using Evive's menu. Connect the servo to servo channel 1. Next, from the menu select controls, then select servos and finally navigate to servo 1. Set the servo angle to 90 degrees using potentiometer 1. Now glue the servo onto the clamp using some hot glue. Attach the clamp to the front of the chassis. Now let's test the soil moisture sensor. Connect VCC to Evive's 5V pin. Connect ground to Evive's ground. Connect signal pin to Evive's A0 pin. Next, from the menu select pin state monitor and navigate to analog pins. Observe the reading next to pin A0 when the sensor's tip is in the open air. The number 1023 will be displayed. Now, dip the sensor into the water. You'll observe that the value will decrease. This means that the sensor is working perfectly. Now that we know that the sensor is okay, let's mount it on the robot. Take the sensor and attach it to the front of the chassis. Now, it's time for making the connections. Connect VCC to Evive's 5V pin. Connect ground to Evive's ground. Connect signal pin to Evive's A0 pin. Extend the servo wires and connect VCC to plus 5V of Evive, ground to ground of Evive, and signal pin to Evive's pin 3. Now, let's make the soil moisture testing assembly. Take an ice cream stick and attach it to the servo horn. Next, glue the probes of the soil moisture sensor to the ice cream stick. Now let's assemble the automatic watering machine. Take a soft PU pipe and glue one of its end onto the ice cream stick. Now, to switch the motor on and off automatically, we'll use a relay. Now we need to add the storage tank. Fasten the 45mm spacer to the chassis. Next, attach the servo horn to the servo head. Now bring the pipe and the jumper cables of the relay to the top and mount the second chassis onto the spacers. Then fix the relay on the top chassis. Time for connecting it to Evive. Connect VCC to Evive's 5V. Connect ground to Evive's ground. Connect signal to Evive's digital pin 10. We will be using a plastic bottle as our storage tank. Take the bottle that is already cut in half and glue it on the top chassis. Now it's time to power up our robot. Attach the LiPo battery to the chassis using cable ties. Next, take the water pump and fit the pipe to the outlet of the pump. Then place the pump inside the bottle. Now, connect the negative end of the battery to the pump connector. Then, take a small piece of wire and connect it to the positive terminal of the pump. Now connect the positive end of the battery to the common on the relay. Connect the wire from the pump to NC on the relay. With this, the assembly of the Agribot is done and dusted. Time to write its code in picture blocks. Since we need to control the robot wirelessly, we are going to write the code in the upload mode. Since the Agribot is a modified 4-wheel drive robot, let's first write the code for the 4-wheel drive robot. The when Avive starts up block will make sure that the program starts running as soon as Avive starts up. The relay connected to pin 10 should initially be off and the screen should be blank. On pressing up on the gamepad in Dabble, the robot should go straight and straight should be displayed on the screen. Similarly, on pressing down, the robot should move backward and backward should be displayed on the screen. The robot should turn left on pressing the left arrow and left should be displayed on the screen. Finally, the robot should turn right on pressing the right button and right will be displayed on the screen. Till this point, we have written the code for controlling the robot's movement. Now let's write the code for sensing the soil moisture level and watering it. On pressing the triangle button, the servo angle should change to 0 degrees, thus inserting the terminals of the soil moisture sensor into the soil. If the reading of the soil moisture sensor at analog pin A0 is more than 800, it means that the soil is dry. Therefore, the motor should turn on and water the soil. Once done, it should turn off. Finally, on pressing the cross, the servo should return to its original angle. But what if nothing is pressed? In that case, the robot should stop moving and brake should be displayed on the screen. Upload the code to Avive and watch your Agribot take care of the soil for you.